All right. Good afternoon, mathematicians. Um, so, like I promised on Instagram, I'm going to be walking through this practice guide for integrated math all throughout the summer. So it's not gonna be an everyday type of thing, um, but I am gonna try and make my way through all of the lessons within this guide. Okay. To hopefully help you guys if you get stuck or have questions. Um, So with that, let's go ahead and begin. Okay, so this very first section here, it's all about diamond problems. And what I love about diamond problems is that and what I love about this curriculum right here, actually, it says, diamond problems are an excellent way of practicing addition, subtraction, multiplication, and division of positive and negative numbers, decimals, and fractions. Sure, that's the most obvious thing, but eventually, as you guys dive deeper into algebra, you guys will get into these things called binomials and factoring, and this is a direct application of that. Okay, so we have some practice problems here. Okay, I know they give us the answers here, but we're just gonna block them off so that way you can't see them. Obviously, as you go along, you want to check your answers. Um, so that way you know that you're doing it correctly. Okay, let's get into this. So a few things before we get into it. Remember that the top part of our diamond, this is going to be our product, the product of the left and the right squares. Okay, and then the bottom part of our diamond here, this is going to be the sum of our left and right squares. Okay, so if we were to do a little bit of mental math here, to find the product of 4 and negative 8, I'm going to multiply those two things, so I get negative 32, and then the sum of 4 and negative 8, 4 plus negative 8, that leaves you with negative 4. And there we go. Also, what I love about this is that they don't always give us the left and the right squares. So instead, maybe they give us a product, or they give us a sum, or maybe they give us the product and the sum, but it's our job to figure out, basically to fill out the empty squares here. Okay? So let's go ahead and look at number 2. So I know that negative 2 and some number, x, if I multiply those two together, that equals 8. So if I ask myself, well, negative 2 times something gives me positive 8. So I know that the sign of my other factor here of this x should be negative, right? Because a negative times a negative gives you a positive number, which is what we want. Okay, and then I just need to ask myself, 2 times what is 8? Well, that's 4. So my answer here, or not my answer, but my other factor here, I'm going to do this in black, should be negative 4. So negative 4 times negative 2 does indeed equal 8. And then now I need my sum, so negative 2 plus negative 4, and that is negative 6. We're on our way. All right, they give me a sum for number 3. They give me a sum of negative 7 and I guess a factor of negative 1. Okay, so let's figure out what we need. So again, I'm missing this other factor here. I'm calling them factors because we have to multiply them, and factors are typically what we call those two things we multiply. Well, let's figure out what can I add to negative 1 to get negative 7. Well, if I write a quick equation of this, so negative 1 plus some number that I don't know is going to equal negative 7. And using my properties of equations here, I can solve for the x by adding 1 to both sides. Right, so these cancel out. X is equal to negative 7 plus 1, which is negative 6. So my right side, my right square here, is going to be negative 6. So negative 1 plus negative 6 does indeed equal negative 7. And then negative 1 times negative 6 is going to give me positive 6. And there we go. All right, moving on. Ooh, here's one where they give me only the product and the sum. So for this one, I recommend writing the factors of 6 because that's gonna give us a bunch of numbers to work with. Okay, so the factors of 6, I'm thinking of things like 1 and 6, 2 and 3, and then we have 3 and 2. You know, just the numbers flipped. okay? And what's nice is that you can play around with the signs of these factors. So you can make this a -1 and a +6, or a -2 and a -3, and so on and so forth. But your job is to find the two numbers that have a product of -6 and a sum of +5. Okay, so immediately my brain is saying, oh, well, I need my product to be a negative number. So I know that a positive...
I'm reminding you, water the plants.
...times a negative, that's Alexa. Alexa's reminding me to water my plants.
I'm reminding you.
Thank you. All right, sorry. A positive times a negative leaves me with a negative. So I already have my signs figured out here. I need one positive number and I need one negative number. Okay, and I know that 2 plus 3 does equal 5, but remember, I need one positive and one negative. So if I were to add, say -2 and +3, well, -2 plus 3 is 1. And that doesn't come really close to 5 there. Or if I do, what if I do -3 and +2? Well, -3 and +2 equals -1 when I add them together. So I don't think these factors in the middle are going to work here. So, sorry. So let's try a 1 and 6 combination. I'm going to try -1 and +6. Right? I know that equals -6 when I multiply them together. And then if I do -1 plus 6, hey, there we go. I got my +5. So my two factors here are -1 and 6. And there we go. All right. We're going to step up the challenging level a little bit here, and we're going to work with some decimals. So the same concept, I'm looking for the product and I'm looking for the sum. Okay, so let's go ahead and start with the product here. I do not have a calculator, so I'm going to multiply these two things by hand. So that's 16, 2 times 3 is 6, plus 1 is 7. 1 times 8 is 8, 1 times 3 is 3. We're going to add these together. 15, 4, and I have two numbers behind the decimal, so my answer is 4.56 as my product, 4.56. And then for my sum, I'm going to add these two together, so 3.8 plus 1.2, so that's going to be 4.0. I'm sorry, 5.0. I am going crazy. There we go, 5.0. All right, let's keep going. So here, they give me one of my air quote factors and my sum. So I know that 8.1, right? 8.1 plus some number that I don't know is going to leave me with 3.1. Okay? And I highly suggest you guys get comfortable with writing equations like this because it's a necessary skill that's never really going to go away. The more you do math, the more you will be using equations. Okay? So let's go ahead and solve this equation. I'm going to subtract 8.1 from both sides. So it looks like x is going to be equal to -5. All right, and now I need to find the product of those two numbers. So 8.1 times -5. So remember, we're gonna save this negative sign for the very end. So we're just gonna multiply like normal. So 5 times 1 is 5. 5 times 8 is 40. And I have one decimal point, so it's going to be 40.5, and a negative times positive is negative. So I'm at -40.5. Let's double check our answers, and we are good to go. All right, next one. Similar setup here. So I know that some number, right, this number that I don't know, I'll label it as x, plus 3.4 is equal to 6.8. In order to solve for x, I'm going to subtract 3.4 from both sides of my equation here. So I should get, I believe x is equal to 3.4. Look at that. The two factors are the same, 3.4 and 3.4. Now I need to multiply these two things together. There's not a lot of room here. You guys may need to use some scratch paper here. I'm gonna move over all the way over here. Multiply this out. That's 13. 3 times 4 is 12. 3 times 3 is 9. Plus 1 is 10. There we go. 5, 1, and 1. And then I have two numbers, two digits behind the decimal point. So I'm going to move my decimal point 2 over. And so I get 11.56 as my product. Should stay color coded here. 11.56. How did I do? Excellent. I got it. Let's keep going. Ooh, this time they give me a product of 9.6 and a factor of 3.2. So remember, I do 3.2 times some number is equal to 9.6. So what I'm going to do is I'm actually going to divide 9.6 by 3.2. Okay, I got to get my long division hat on here. So 9.6 and 3.2, bringing it back to whoops. So I move my decimal place over 1, and then I do the same underneath my division here, and then I bring it straight up. 32 goes into 96. How many times? Hopefully you said 3. So it looks like my other factor is 3. Right, that's 9, that's 6, yep. And I'm left with 0. All right, let's add these two together. 3 plus 3.2, little mental math here. That's going to be 6.2. Let me check our answer. We're at number 8. Excellent. You got it. All right. Upping up the ante a little bit, guys. Moving into fractions. Same concept. I'm going to find my product first. So 1/7 times negative 1/2. Remember with fractions, whenever you multiply, you're just going to multiply straight across the numerators and straight across the denominators. Okay, sometimes there'll be chances for some cross-canceling, but not in this case. So 1 times 1 is 1. 7 times 2 is 14. And then we have a negative symbol in there because a negative times a positive is always negative. So our product is negative 1 over 14. There we go. Now let's find the sum. Remember the sum with adding these. We need common denominators. Okay. Now I'm thinking the common denominator that I can use for these two is 14. So I'm going to multiply 1/7. I'm going to multiply the numerator and the denominator by the same number. So I get 2 over 14 plus, and then for negative 1/2, I'm going to multiply the numerator and the denominator by 7. So I'm at negative 7 over 14. So when I add these two things together, I'm going to keep my denominator, right? So my denominator is 14. And then now I have 2 plus negative 7. So I'm left with negative 5 over 14. And that's what I'm going to write in my diamond. Woo! Not too bad, not too bad, am I right? Okay. Number 10. Here we go. Here's something interesting. So I know that I'm going to work down here. So I know that 1/5 plus some number is going to be equal to 3/2. Okay, again, let's make these have the same denominator, so that way our addition and subtraction will be seamless. So I'm thinking 10, right? 5 times 2 is 10. So I'm going to multiply the numerator and denominator of 1/5 by 2, so that becomes 2 over 10 plus x. And then for 3/2, I'm going to multiply the numerator and denominator by 5, so I get a common denominator of 10. That's going to be 15 over 10. Okay, and now I can solve for x. I don't want this 2/10 here, so I'm going to subtract 2/10 from both sides. Well, 15/10 minus 2/10, this is starting to look really sloppy, I'm sorry guys. X is equal to 13/10. And we're just going to leave our answer like that because why not? Right? Improper fractions never hurt anyone. All right, let's keep going. Now we need to find a product. Excuse me. I'm starting off this summer so well. I got sick already, guys. All right, so product 1/5 times 13/10. Well, I'm multiplying straight across the numerators and straight across the denominators. I don't see a chance for cross-canceling here. So 13 over 50 is my answer. 13 over 50. And there we go. All right, let's keep going. I'm going to have to erase some of my work here, guys, so I have room. Why is this eraser so small? Well, okay, let's do that. Okay. So, I know that 9/10 times another number, x, is equal to 9 over 5. Okay, so I don't know if you guys remember, but when we were solving these equations, whenever you have a fraction, right? Whenever you have a fraction as your coefficient to your variable, in order to solve for the variable, you must multiply your fraction by its reciprocal, right? So the reciprocal of 9 over 10 is 10 over 9. So I'm going to multiply by the reciprocal in order to cancel these out and leave x by itself. Okay, and then what you do to one side of your equal sign, you must do to the other side. And there we go. So I see a lot of opportunities for cross-canceling here. I know that 9, right? 9 goes into 9 one time, right? So both of these are going to cancel out to a 1. All right, and then how many times does 5 go into 10? 5 goes into 10 2 times, and then whoops, and then 5 goes into itself just once. So I'm left with a fraction, so x, right, bringing this x down, 2 over 1, or x is just equal to 2. So that's my other factor. Whoops, I should have done this in the black color. There we go. So x is equal to 2. Now I need to add my two add my two numbers together. So let's do that really quick. 9/10 plus 2 is equal to some number. Let's change 2 into a fraction with a denominator of 10. Okay, so I'm gonna do that down here. 2 over 1. I need to get my denominator to a 10, so it looks like I multiply both the numerator and the denominator by 10. So I'm going to add 20/10 to 9/10 for a total of 29/10. And that is my sum. How did I do? Excellent. There we go. Okay. Number 12. All right, we are given a sum and a number. So I know that x, right, some number plus 1 is going to give me 4/3. I'm going to go ahead and change this 1 into thirds. So I know that 3 over 3 is the same as 1, right? And I want to get that variable isolated by itself. So I'm going to subtract 3/3 from both sides. So I am left with x is equal to 1/3. And there we go. That is, whoops, wrong button. That is my answer for the left square. So x is equal to 1/3. Now I know that I need a product at the top. 1/3 times 1 is the same. It's just 1/3. And there we go. There's my answer. All right. Here's where we get into some little bit of algebra, right? We add some variables into the mix here. Okay. So we have two factors, x and v. Let's multiply those two things together. Well, x times v is the same as xv, so that's what I'm going to write. Oh, I'm sorry, that's supposed to be a y, but mine is cut off. So, okay, I'm just going to make this look more like a y, so that way I don't get confused. Okay, so our product is just x times y. So that's what I'm going to write here, xy. Next, I need to add them together, x plus y. That's exactly what you're going to write, just x plus y. Because they're two separate variables and there's a possibility that they are not the same thing, we cannot add them together, so we just write x plus y. So there we go. All right, next one, number 14, almost done, you guys. So I have a product of a squared, a to the second power. Remember, a to the second power is the same as a times a, right? That's in our expanded form. Hey, look at that. I just gave you the other factor. So I should have another a in the right square there. So I have a times a, that gives me a squared. Now, what happens if I add a plus a? Well, how many a's do you have in total? There are 2 a's. So your sum is 2a. And our answers check out there. Awesome. Let's keep going. I have a sum of 2b and I guess a factor, I'll just keep calling it that, of 8b. So sorry if that's inaccurate, but we're just working with what we got. So remember, this 2b is a sum. So I'm adding a number that I don't know, x, plus 8b is equal to 2b. So to solve for b, or not, what am I doing? To solve for x, I'm going to get rid of this 8b here. So I'm going to subtract 8b from both sides. So I know 2b minus 8b, that's going to be negative 6b. And that's going to be my answer here. So negative 6b. All right. So now I'm going to multiply these two, negative 6b times 8b. It might help to separate these. So I'm going to just do negative 6 times 8. So that leaves me with negative 48. Okay, but don't forget there's variables attached here. B times b is b squared. So our product is negative 48b squared. And there we go. All right, last one. I have a sum of 7a. They give me 3a. So I know that 3a plus some number that I don't know is equal to 7a. I'm going to subtract 3a from both sides to solve for x. So I know that x is equal to 4a. Now let's multiply these two things together. 3 times 4 is 12, and a times a is a squared. And there we go. All right, hopefully this is making sense to you guys. This is, like I said, this is a great skill for you guys to be able to do, especially when you get into to more complex algebra. All right. Well, there are your diamond problems. I will see you guys in the next lesson.